So I'm going to go to a whiteboard, and this is number 9. And this is something that you guys are like, we introduce it in Alg2, and then you do see it again in pre-calc if you're a pre-calc person. So if you're like, this seems like a really short run through, and will I ever understand this? Like, you'll get to go through it again, but it's just good to see. And this is just, yeah, if you're someone who's math nerdy, this is just really good. So the 3-way systems I gave everybody a couple of days ago were super, super easy because it already had one letter by itself. But this right here, my friends, is the prime reason we have elimination, is when we solve systems that are bigger than 2. So we're just going to solve this bad boy. If some of you guys took a stab at it, that's awesome. I'm going to kind of guide you through the first part, but you guys might be able to finish it for me. So basically what I'm going to do is I'm going to add these 2 equations together. Is that okay for everybody? So I'm going to pretend it's like elimination. I'm going to add these guys. So 2x plus 3x is 5x. Everybody good with the fact that the y's go away? Mm-hmm. Cool. And then plus 3z equals 24. So everybody feel pretty good about that?
Yes.
Sweet. Now here's the thing. If we actually want to solve this system, what we have to do is we just used these 2 equations, right? We just used the top 2. We would either have to use the bottom 2, or we'd have to use the bottom first one, because we can't use the first 2 again. Like, we'd have to use something different. I'm going to use the bottom 2 just to make it kind of easier to visualize. But if we use the bottom 2, everybody, and we added those together, would anything cancel out right now?
No.
No. So the easiest way that I see is to multiply this equation by -2. Would you guys see that the y's would cancel out then?
Yeah.
Yeah. Now the thing is, I actually did that on purpose, because like technically we could have also maybe like multiplied the bottom equation by -3, right? And then the x's would cancel. But whatever we canceled out the first time, if you guys look at the blue equation we have no y's in here. Whatever we canceled out the first time, we have to cancel out the second time. So that's why I actually have to multiply the first equation by -2. So then I'm just going to come over and do some side work over here off to the side. So that's going to be -6x minus 2y minus 12z equals -8. So that's what I get when I apply that. And I'm just going to bring this one down too. I'm not going to do anything to it. I'm just going to bring it down. X plus 2y plus 9z equals -16. And then I'm allowed to add these together now. So I get -5x. These go away. -3z and -24. Dang, I did not expect that to happen. Whoa. So everybody, now do you see how we have 2 equations that just have x and z in them?
Mm-hmm.
Boom. So now what we'd actually do is we'd actually do elimination on these. So I just bring this guy down here. I didn't even know I gave you guys this one, this crazy one. What happens to these things?
Everything just goes away.
Disappears.
And do you guys remember what that means?
Infinite solutions.
Yes, this actually means that we have the same, this is actually in 3D space. Instead of the same line, we have the same plane in 3D. Wow, my brain was just blown. But even if all those didn't cancel out, let's say just the z's canceled out. Once you guys had x, would you guys be able to plug x back into the blue equation and find z?
Mm-hmm.
Yes.
Right, and once you had z and x, you'd be able to plug it back into a green equation and find that. So I wanted to show you guys that one because I thought it was pretty cool. I don't give one of those on a test. I just give it as extra credit, but you'll actually see a couple of those in pre-calc. How you guys feel about that? Pretty good.
Better
Sweet.
than I did 3 minutes ago.
Excellent. So now we're going to jump to, you can feel free to look at the packet if you want, but we're going to jump to the notes for today. And you guys being on the call today gets you guys like, so you don't have to worry about doing anything else after this call. And then you can enjoy your weekend and be like, freedom. Well, at least for math anyway. Yeah. I do not have freedom because I have to figure out the calculus and trig finals for Kaskaskia, but that's okay. Okay. So here is where Alg2 comes in, my friends. Linear, quadratic, like those words, linear means line. That's probably pretty obvious. But quadratic, do you guys remember that that means parabola?
Yes.
We're putting the math vocabulary back into your life, you know, now that we're out of school for a little while. We might need to do that. So if we take a look here, this is where your graphing calculator can come in handy. If you're like, man, I can't remember how to graph these, but this is actually the most basic parabola. Do you guys remember where the most basic parabola starts?
0, 0.
Yeah. And it's got the normal slope of like 1, but actually goes up to 4. So it's like there. Right. So it's like, woo. There it is. And then this thing, we've already reviewed graphing lines, this packet. This is 2x plus 0, right? There's nothing over there. So it'd be like 0, up 2 over 1, up 2 over 1, boom. So if you remember, when we earlier in this packet were just doing lines, we were looking for where the lines met. But now they're not going to all be lines. That is the beauty of Alg2, my friends. All right, what we've been working up to this whole time, even though we've been doing Algebra 1 review, has been we are working up to solving things that involve parabolas and other things that you guys know how to solve. And it's awesome because then in calculus, you get to solve so many random things. Great. But that means how many times do these things meet together?
2.
Yeah. So that means this point right here, the 0.24 is an answer. And that means the 0.00 is an answer. So there's actually 2 solutions. Wow, we've been out of school for a long time. Here we go. Okay. There are 2 solutions to this guy. And they're right there and right there. So that is beautiful. All right, so that's what's going to happen when we have when you have lines, they pretty much, the lines cross and they meet at one spot. When you have sometimes we're going to talk about where 2 parabolas meet, so that gets a little crazy as well. But you don't necessarily just have like no solution or infinite solutions or one solution. Like there's definitely some other possibilities out there. So that's what we need to talk about, is the other possibilities. So how's everybody feeling so far?
Good.
Cool. So then if I come down here, here's the next 2. All right. Now this is where I'm going to refresh you, just because it's great to do right now. I'm going to refresh you on how to graph this guy. Because that's been a while, but we should know how to graph the line, right? But in case you don't, I am going to, I already have them plugged in from when I was doing this earlier. This is great. So I'm actually going to come back to Zoom, stop sharing my screen for a minute so I can flip my camera. Where is the camera flip? There it is. So I have this typed into my graphing calculator. How's everybody feel about that, right? So you go to the y equals screen. The y equals button is up here. And then you'd have to type in all this stuff, right? And so your x button is the one next to alpha, which is kind of like reviewing all that. And so you do like x squared plus 6x plus 8. If for some reason you're a person who forgot your graphing calculator at school or something, Desmos.com, my friends. I can write that down once we get back to the other screen. It's amazing. You just go there and it graphs it for you as well. But then once you have both of them typed in, usually I tell you guys not to type in more than one thing at once, just because it can get cluttered. But this is that spot where it'd be a really good idea to type them both in at once, because you want to see where they meet anyway, right? And then I'm going to press the graph button, which is over to the right. And so therefore, that is our graph. How you guys feeling about that?
Good.
Cool. So now I'm going to share my screen again. Guys, I just want to say I'm quite proud of myself. Not that I'm like super old or anything, but I've learned how to use the technology. Just saying. Okay. So if you don't have your graphing calculator, DESSMOS.com. This is a great tool. But we saw on our calculators that 2x minus 6 was like down here 6 and then up 2 over 1, which we probably knew. But then the question was, where was this guy? If you want to remember how to graph this by hand, you may still have a construction paper booklet. There is a chance. Now, granted, it might be in your locker, but it's like that x equals negative b over 2a thing. and B is 6, and then A is 1, so that'd be -3. And then you plug -3 back into the equation, which is 9 minus 18 plus 8. -9, -1. So then -3, -1, and then you got your parabola from there. So that is why I'm going to let you use your graphing calculators. If that helps you be like, I can't remember to graph all this stuff by hand, that's fine. So if you take a look there, where do these guys meet?
Nowhere.
Nowhere.
Nowhere. And I don't think they're going to meet anywhere with me. Because the green thing's going to keep going like skinnier and the red's going to be a constant pattern. So this is a case where there's no solution. So things don't have to be parallel anymore to have no solution. Does that make sense?
Yes.
Sweet. What do you guys think about, so what are the other possibilities that we could have? So we just saw that they could meet in 2 spots. They can meet in no spots. What else do you guys think?
They can meet in only one.
Yeah, what would that look like?
They would only meet at the 0, 0.
And it depends on where they meet, but this one, and so actually this one is the one solution. So nice prediction, Courtney. I'm going to write that down right now. This one is, do you guys remember what the line y equals -6 looks like?
This is a straight line at -6 down.
Yeah, flat at -6. Nice. So it's right there. And then this guy is actually just down 6 and your parabola. So what do you guys think? Does that make sense that that would meet one?
Yes.
Yeah. And I'm actually going to tell you guys, that's the really obvious one when it's just down right there at that moment. People who are super math nerdy, who are going to end up in my class 2 years from now because they're going to take calculus. So my home slices who are going to take calculus, that should be several of you hopefully. We talk a lot in calculus about lines that just meet a curve. It doesn't have to be a parabola in particular at one spot. And we end up calling this a tangent line, probably because of that word, not the word tangent like sine, cosine, and tangent. But do you guys remember that word tangent from geometry, like when there was a tangent line to a circle?
Mm-hmm.
Yes.
That is this idea, and it's where things only meet once. So that ends up being like something that we actually talk about and do in calculus a lot. So this is like a super, super important topic that we're kind of touching on right now in Algebra 2. But don't be scared. Literally all you guys are going to be doing for the next couple of days is like thinking about, okay, where are the places that they meet? How could we find them? And instead of just doing it by graphing and letting your graphing calculator solve it, you guys are going to be doing substitution and elimination. But it just means that there's more of the box. If you miss the box, then there you go. So what do you guys think? Anybody want to talk me through what one of these things look like, or how many times you think they'll meet? Or type them in your graphing calculator and you guys can tell me how many times they meet.
They won't meet at all.
Yeah.
Aha. Because this is the regular parabola, right? Like this.
Yeah.
But what's this line look like?
It's down by 1.
Yeah, it's flat. So this is another no solution. Everybody feeling good about that?
Yeah.
Cool. I think I have one more slide. 2 parabolas. So basically, let's kind of go up here to recap. Whenever you have just like a line, here we go, a line in a parabola, you've got really 3 options, right? It could open, we haven't done any downward opening ones, but it could open downward and have a line go through it, and it could hit twice, right? So it could be 2 solutions. You can have it where it just hits once. We talked about that, right? Either the bottom or somewhere else. So it could just hit once, barely touch it. You could have 1 solution. Or you could have no solutions, right? Because it could be a line that's down here and a parabola that's up here. So there's 3 options, but you can't have 3 solutions, right? I don't think, because a parabola doesn't turn around. So
No.
it's going to be one of these options. And you can't have infinite solutions because a parabola and a line can't overlap anywhere. As soon as you have 2 parabolas, we can overlap each other and have that. So actually, let's talk about that in a second. So the next kind of other thing that you're going to be doing next week, and we're going to just do one of today, is where two parabolas meet. What are our options for two parabolas?
Two
So
solutions.
yeah, we could have two solutions. What would two solutions look like? Well, typically, yeah, go ahead, Courtney.
Well, you would have one parabola, but you would have like an overlapping area where they would meet at 2 points.
Yeah, I mean, there's one way to think about it is just one opens up and one opens down. Does that make sense to everybody? When those two things just meet in those two spots right there.
Mm-hmm.
And technically, though, I just did one with calculus the other day. It was with sideways parabolas, so that was crazy. We had one open like this, but then we had one that was on the inside of it that opened wide. We won't be doing sideways parabolas, but those also met twice. So you can have two solutions. Let's see here. I just said you could have infinite, right? So now we could have infinite because they could just literally perfectly be overlapping, right? So we could have overlap and overlap. Could we have one solution?
Mm-hmm.
What would it look like if they had one solution? So that means they'd only be able to touch once.
Like if they're one opened up and one opened down and their vertexes touched.
Yeah, perfect, Ethan. You got it. So if they were like this, then they'd be like, oh, right there. We got one solution. So one solution is possible, two solutions possible, infinite solutions possible. Are three solutions possible?
No.
No, I don't think so. So we won't see three solutions until we have like cubic in a line or something like that. Or
But isn't no solutions possible?
Yes, very nice. No solutions possible because one could open down and one could open up, and they could just like one could be over here and one could be down here, right? And they would never touch. Some people get confused though. No solution isn't necessarily one over here and one over here because off the graph they'll end up meeting like way up there. So be careful with that. But nice. So those are all the possibilities for two parabolas. Everybody feeling okay about that? Sweet. So now, why don't you guys, I'm going to try to see if I can graph these by hand, but why don't you guys plug these two in your graphing calculator? This is our last one for the day, I think. Yep. You guys plug those two in your graphing calculator, and I'm going to try to graph them by hand. I don't know which method I'm going to use yet. I think I'm going to use this method for this one. This one is -6 over 2 times -1. 3 comma, I'll plug 3 back in. That's -9 plus 18 minus 4. -9 plus 18 is 9, 5. And this one just opens like this. Are you guys getting something like that?
Mm-hmm.
Yes.
Yeah.
Nice. So just to recap, I used the method of the construction paper booklet for the bottom one that's in orange. And if you want to know how I did the top one, which I did in purple, I pulled an X out and then I set both of those equal to 0 and I got X equals 0 and X equals 3. And this might be a long time ago, but you guys remember when we did like graphing on the floor this year?
Mm-hmm.
Yes.
And so then we put 0 and 3 on the axis and then we just counted to the middle. But basically what I would just be looking for today is we're going to start looking for exactly where they meet soon, but not today. I mean, where they meet would be, well, I'll highlight that in a different color, but would be like right here and right here. But what I'm just looking for today is how many solutions does this thing have? And so the answer to how many is how many places does it meet?
2.
Boom. So that's kind of what I wanted you guys to wrap your brains around to launch into next week where we do all the Algebra 2 type stuff. How you guys feel about that?
Good.
Sweet. So I'm going to come back here. I'm going to stop the recording. So I'm going to put that up there for people who might want it.